Hi, everyone. Thank you so much for attending my talk, The Evolution of AI Search. My name is Dustin Coates. I've been working at Algolia since 2015 in a number of different roles in search. I've worked directly with our customers to implement their search experiences. I focused on voice and natural language search. And these days, I work as a principal product manager on all things AI search and search ranking. Additionally, I've written a book for a major tech publisher on building voice applications. I've co-hosted a podcast for many years on the same topic, and I've also have a newsletter and blog called Talking to Computers, which is all about information retrieval, natural language experiences, voice, and conversational. As you can imagine, over the previous decade, I've seen a lot of change. When I first started Algolia, data was less important. It was important, but there wasn't much of it beyond that textual data that was being used for relevance and for filtering. The other data, especially event data, really didn't take a starring role. Mainly, it was used to break ties whenever records were tied textually. We still do that today through our custom ranking, but event data, clicks, conversions, revenue, all of this data has played a larger and larger role. I've been really fortunate to work on many different AI search products here at Algolia and work alongside very smart people who are working on those similar products. Through this, I've been able to see how our data needs have changed at Algolia and how our customers' data needs have changed as well. Let's walk through that a little bit. Fairly early on, we released personalization capabilities to our customers. The important thing to note about how we approach personalization is that we gave our customers near total control over the system. This is something that we've always given a lot of thought to at Algolia. We want to bring our search expertise to our customers so that they don't have to be search experts. At the same time, our customers are experts at their businesses and their needs. And that's one of the first lessons of building AI. It's humans plus machines, not machines over humans. Another early feature we released in this vein was dynamic re-ranking back in 2019. It uses a statistical model leveraging click and conversion events to increase overall search conversions on queries. By taking those events and running them through the model, we can push the more desirable results up top and push the less desirable results down to the bottom. Of course, we kept the idea of control in mind, and our customers are able to turn the feature off for individual queries or override the ordering manually. Dynamic re-ranking and our personalization feature have worked fantastically for many hundreds of customers. These two features show that even sometimes a relatively simple model can have a huge impact. Of course, our foray into intelligence didn't stop there. An early AI product that I got to work on was called Algolia Answers, which we started building out in February of 2020. It was a question and answer search that used an LLM for understanding and ranking and primarily targeted support use cases. With it, we were actually launch partners on the OpenAI GPT-3 API, which means that we have been working with these kinds of LLMs since early 2020. If you think about it, ChatGPT came out a few years later, so we've been working on this for a really long time and we really learned a lot. In truth, the immediate data needs for that product were quite small because OpenAI had fed so much data into GPT-3 and the models they and others like them have since built. We were really only sending data at query time. This was great for a while because we could spin up a product really quickly and start delivering value. However, we quickly hit a wall. Algolia Answers was magical when it worked, but it had a few challenges. One problem was that it was hard to understand why results came back in the order they did. LLMs aren't the best at explainability, and that's important for us and our customers. Remember, we need to provide control, and if you can't understand, you can't control. The other problem was that it was very difficult for our customers to use their own data to influence that ranking. For example, we had a news website that wanted to bring in freshness. The newer articles should be at the top. For example, if you search for President Middle East conflict, you would have content from the past year at the top. But if you search for President Geneva Summit, you would get results from the 1980s because there hasn't been a Geneva Summit recently. The model was so heavyweight that we really couldn't override that. This is one of the lessons from this product. Especially with newer, larger LLMs, you may be able to build an ML product without pulling in much of that data, but you will quickly find that unique needs that can't be addressed by a one-size-fits-all setup. Of course, this again ties into that initial lesson around giving customers control. If people can't understand why results are ranked where they are, and they can't override a heavyweight model, then do they truly have control? No, they really don't. So we took a step back. Algolia Answers, however, did show a lot of promise, and it gave a lot of benefits to our customers that used it. But it didn't give that control, it was also a little slower than we would have liked, and the use case was too narrow. We want to solve semantic search for everyone. So we went out and inquired at company Search.io in 2022, which led to Neural Search, first released in May of 2023. It uses neural hashing technology to be blazing fast and combines results from both keyword results and vector results into one single result set. This is ideal for use cases like e-commerce and others. This product is interesting because it requires click and conversion events in order to work. It's not a ton of events that are needed, but enough that our customers can't see a value as immediately as they can with keyword search. This isn't really a problem with something like dynamic re-ranking, which also uses clicks and conversions, because it's easy to conceptually understand we push the results higher that are more attractive. However, with something like vector results, you really want to understand what that vector retrieval was sending back. So we have looked into ways that we might be able to show that value to them a lot more quickly. Because otherwise it's tough to say, just trust us that this is great and come back later to see. This is the next lesson to share with ML, especially ML that uses individualized data. It's vital to do whatever you can to show that value right away, because it can take some time to show value from it. What we have done is set up things around onboarding that help give the users a sneak peek at how results are going to look for the users when it's in production. We're also investing heavily in solving the cold start problem, so that customers need less or maybe even no event data before they see value. In building our neural search, we also saw that we had to provide a good way for customers to fix the results from the models when they didn't align with what they expected. With ML, there will occasionally be situations where the model returns results that aren't quite what you had in mind. Now, most of these aren't even wrong, maybe just not right in context or right for that judgment. This again ties back into that very first lesson of control. Try your hardest to give an exit for unexpected ML results. They'll always be there. Ideally in very small amounts, but they will always exist. And unless you know about how common these bad results are, the less surface area you should cover in your first iterations. So we've started providing some strategies to our customers. We can allow the customers, to choose, I want to be a little bit more conservative, and so I want the vector results to only come in when there's few results in the keyword results, or I want to be maybe a little bit more aggressive and I want them to be seen more often. This ties in to the project that I'm working on now, Learning to Rank. It's still really early, but it's all about integrating that into our search engine. Learning to Rank uses ML models to do exactly what it sounds like, learns the ideal ranking of results based on many different factors. For example, the model might make the number of purchases for each product, the number of views on each product, and the number of typos between the product's title and the query. In reality, there's going to be dozens of these signals, but let's limit it to just a few to conceptually understand. The model will then balance those against each other in order to put the results in the right order. One of our requirements from the very beginning was to have explainability. This was both a technical challenge and a user experience challenge. Which technologies do we use that give us a peek into why results are ranked the way they are? And how do we present that information so that it is both actionable and doesn't overwhelm? Again, remember, we might have dozens of different signals that are feeding into the model. And if you try to throw all of those to someone at one time, it's not going to be very understandable. And if you can't understand, you can't control. The biggest challenge as well, or another big challenge rather, we are having with this project is also getting the data so that we will feel confident when we launch. We are making changes to the ranking order, which is so key. And the only way to really know if those changes are correct is to put them in front of the users. You can use something called judgment lists, which are essentially annotated lists of which results are good or bad, created entirely by humans by hand. But these have problems too. When things are created by hand, they are expensive and they are cost intensive and time intensive to create. And there's also no promise that the people who are creating those judgment lists have the same point of view as the people who are also doing the searching. Plus, if you add in a feature like personalization, which is unique to each individual searcher, those judgment lists become essentially worthless. What we are doing then is to take a look at how much the results are changing and trying to align that with what people are already doing with the search results, which results they're converting on or clicking on the most. Now, it's not perfect. You won't know for sure until you get to production traffic, but it shows us directionally the impact that we will have. And that's the next lesson. Try to get data ahead of time that you know will help you test your efforts, but don't expect to be super confident at the end. You have to test with real traffic. In testing with the real traffic, just continue to follow those product development best practices. Start with a small percentage of traffic, for example, 10%, but you also want enough to actually get results. This can be, up to even 50% if the expected effect and the expected traffic is small. Now, a lot has changed since 2015 in terms of how we use data to improve the search results. In addition to those features and products that I already discussed, we've also released recommendations, query categorization, AI synonyms, and more. We have AI personalization in beta now. The consistent thing through it all, though, is that we only use AI when it adds to the experience. We don't start out by asking ourselves, how can we throw AI in here, and then ask what problem that AI is solving. We start with the reverse. We are always looking at what problems our customers have and looking at the solutions for that. If AI is the solution, great, let's use it. If it's not, then let's use something else. We're always very respectful as well about customer data. Your data is your differentiator, and you want to know that it's treated well here at Algolia. So let's look at the lessons one more time. First off, always allow for control, or in other words, allow for agency. The users of the search, the people creating the search, want to know that they can change things if they need to. Sometimes simpler just works as well or better as more complex solutions. You really want to show that value right away. This can be difficult when something that relies on a lot of data or has to build the model, but really try to solve that cold start problem as much as you can. ML explainability is key. Again, tying back into that idea of agency and control. If you can't understand, you can't control, you don't have agency. And practice trumps theory. Test as much as you can, but until you get that out in front of customers, or your end users rather, you're not going to know for sure if it's actually having the impact that you expect. So try to test as much as you can again, but really try to take those product development best practices and put those in front of users as early as possible. And then finally, don't start with AI, start with a problem. Thank you so much for attending this session. I want to give you one final bonus lesson, which is a book that I found just really incredibly valuable, which is called Building Machine Learning Powered Applications. This goes into a ton of detail into how to build these. And one of the things I loved from the author is the idea that the first time should always be handmade. because you start to learn when you do that handmade. You learn what some of the constraints are, and sometimes actually that handmade approach might be the final approach. Again, thank you so much, and be around if you have any questions.